Hello viewers, today we are going to discuss about the OSI reference model. In the previous session, we have discussed about the TCP/IP protocol suite with different types of network models. So in that one, the first one is TCP/IP protocol suite, and the second one is the OSI model. So today we are going to discuss the OSI model. I am Dr. Ramadevi from Institute of Aeronautical Engineering, Hyderabad. Let us start this session. So let us see what is open systems. See what is this OSI model? The full form of OSI is Open System Interconnection. So how the open system will be, and then how they are interconnected. I let us discuss today. So what is this open systems logical progression? Is the proprietary system. What is a proprietary system? A system that uses technologies it kept private by a particular commercial vendor. So proprietary system means the system which uses whatever the technologies a system is using, which will be kept as a private that is it is for the commercial vendor purpose. Interoperability. What is interoperability means? It is the ability of software and hardware on multiple machines and from multiple commercial vendors to communicate. So open system means it is a logical progression of the proprietary system, and the interoperability means it has the ability that the software and the hardware on different multiple machines. They are from multiple commercial vendors to communicate. So whenever the commercial vendors has to communicate with multiple machines, so this we say that the term as the interoperability. So open systems. What is an open system? A system based on a common model of network architecture and a suite of protocols used in its implementation. So what is the open system? Is open system means it is open to all. That is, it is a system which is it is a common model. It is a model which is a universal model for a network architecture. Open system is nothing but a universal model of a network architecture, common model for everybody, and a suite of protocols, and they consist of different protocols, and it used in its implementation. So how these open systems are implemented? With the help of the protocols, it is implemented. Open system interconnection reference model. So open system interconnection reference model has 7 layers. The layers of OSI reference model. This figure shows the layers of the OSI reference model. We have 7 layers: 1, 2, 3, 4, 5, 6, 7. And first layer is from this is when we start from the physical layer to the application layer. Then when we consider the physical layer as the first layer, then 7th layer as application layer, we call that approach as the down to top approach. Down to top approach. If suppose if the application layer is specified as the number one this one layer, so that may be considered as the high level to the lower level, or it is called as the top to down approach. So those are the so like that the reference model is designed. So first layer it is called the physical layer. Second layer is known as the data link layer. Third layer is known as the network layer. Fourth one is the transport layer. Fifth one is the session layer. Sixth one is the presentation layer. Seventh one is the application layer. So there are 7 layers in the OSI reference model. The open system interconnection reference model, it is a 7-layer logical breakdown. So all these are how they are classified. All these layers are classified as a logical separation of network interaction. It will facilitate the communication standards. So this will facilitate, this gives the communication standards. That's why it is layered as a OSI reference model. Each layer deals with a particular aspect of network communication. Whatever the layers, physical layer, data link layer, network layer, all these, each and every layer has its own network communication aspects. So all these we will discuss in detail in the forthcoming slides. So OSI model, network protocols involved in this one are the network protocols are layered such that each one relies on the protocol that underlie it. Sometimes it is referred to as a protocol stack. What are these network protocols? They are layered, they rely on protocols. All these networks layers, they depend on the protocols. And then they are all these protocols, we call it as some in a big protocol stack. So as you see, layering of key network protocols, how they are layered, it is shown in the network protocols. You will have the internet protocol, transmission control protocol, user datagram protocol, and then another protocol. They are all stacked. So these are all the this one internet protocol is a network layer. It comes under the network layer. Transmission control protocol, user data protocol, it comes under the transport layer, and SMTP, FTP, telnet, all these are application layers. So like this, for example, the layering of key network protocols are shown. So here transmission control protocol, here TCP IP model has the transmission control protocol is a short form is a TCP. So this what it does is that it breaks messages into packets. Here in the TCP transmission control protocol, the software this breaks the whatever the messages we are sending it. It is broken into packets, and then hands them off to the IP software of delivery. And then whatever the here just to explain this scenario here, the whatever the TCP IP protocol is TCP protocol is there here. This will be converted into packets, and then it is sent to the network layer, which consists of the internet protocol. So here, how to discuss a model? Let us consider this one. So the software that deals with routing of packets through the. So these packets, here transmission control protocols, this software breaks messages into packets. So whatever the software is there, this makes the message into packets. It is divided into small segments, and in the TCP IP, it is divided into packets, and then this is handed over to the IP software for delivery. So internet protocol software for the next layer it will send, and then the orders and reassembles the packets of the destination. So this one, whatever the software is given to that one, that IP it orders and again reassembles whatever the packets are there at their destination. So all these packets contains the details of the destination, address, source address, all these things. So it will forward to the destination. Internet protocol. This is so here after from the TCP IP, when it is given to the internet protocol, the protocol layer, the software that deals with the routing of packets through the maze of interconnected networks of the final destination. So after this one, the internet protocol is interconnect these networks to the final destination. In the TCP IP, we have another protocol called User Datagram Protocol (UDP). This is an alternative to the TCP. TCP is for the connection-oriented services, and UDP is for the connectionless services. It is a connectionless service-oriented protocol. It is an alternate for the TCP. So this is faster but less reliable. It is the datagrams are provided very in a faster rate, compared to the TCP, but the reliability of this one is very less. Ping. So what is a ping? A program used to test whether a particular network computer is active and rechangeable. So what is a ping here? This ping is a program. So this is used to test whether a particular network computer is active and reachable, whether it is active or not, whether it is reachable or not, whether we are able to access that one or not. That is nothing but ping. It is a program. Trace route. So a program that shows that route a packet takes across the internet. So this is the trace route is also a program. So which shows that whether the route a packet so shows the route a packet takes across the internet. Whether the routing of the packets have done across the internet or not. This trace route program is used to identify that one. So here the high level protocols in the OSI model are this one. Other protocols built on TCP IP protocol suite are the simple mail transfer protocol. So this is used to specify or transfer of the electronic mail. So when we are sending the electronic mail, email. So when you are sending the email, this simple mail transfer protocol is a protocol. Protocol is nothing but the rules to be followed for the process. So this simple mail transfer protocol is used to transfer the electronic mail. File transfer protocol is nothing but it allows the user to transfer the files to and from any computer. So any computer or any node to node, the file transfer will take place with the help of FTP. Telnet. It is used to log on to one computer from another. Telnet is used the telecommunication networking. It is used to log on to the one computer from one computer and another computer. If you want to log on, means Telnet is used. Hypertext transfer protocol (HTTP). So this HTTP it will allow exchange of web documents. Whatever the web documents are there, if you want to exchange, means nowadays we are exchanging all the web documents with the help of this protocol is hypertext transfer protocol. So as the daily we are using all these things, say SMTP for electronic mail transfer, and then file transfer protocol FTP for the transfer of files, and then the telnet for log on to one computer to the another computer, and then the hypertext transfer protocol is exchange of documents. So all these things are day to day life we are using it. So which of these you have used all these things? Just notice. So high level protocols, different high level protocols and their ports usage is given here. So here the as you see here the protocol echo, the port number is 7. So every protocol is specified with some port numbers, that is 7. File transfer protocol FTP 21, telnet 23, SMTP 25, DNS 53, Gopher 70, Finger 79, Hypertext Transfer Protocol 80, Post Office Protocol 110, POP3. In short, it is called POP3. 110 it is. Network New Transfer Protocol 119, NNTP. Internet Relay Chart IRC 6667. So all these are some of the protocols with their port usage. MIME types. So what is MIME type? What is MIME stands for? It is nothing but a multi-purpose internet mail extension. Multi-purpose internet mail extension. That means it is a standard for defining the format of files that are included as email attachments or on websites. So this is a standard which will define the format of the files. So if you want to define the format of the files, the MIME this multi-purpose internet mail extension is used, and then it is a format and which includes as email attachments or on websites. So which will include the email attachments or it may be on websites. So sometimes we have some questions. Network, what are all the network questions is over what medium, at what speed, how to address computers, which path, how to handle or detect and recover errors, what services, how to address documents, what data format. All these things are questions related to the networking and networking. So here in this the outline of OSI model is introduction part we have seen, and then what is OSI model we have seen. It is a 7-layer network, and then TCP/IP model. In the previous discussion we have discussed the TCP/IP model. So later on we will discuss about the IPv4 and IPv version 6 in the forthcoming classes. So, in the previous sessions, we have discussed that what is a protocol. So, technically, this is a standard which allows entities. That is, entities means it is nothing but the application programs. So, this standard, it is a protocol, is a standard. So, which will allow the application programs from different systems to communicate. So, this shares conventions from communicating information. So why protocol is used, which is used, these are all the shared conventions. So that convention we have to follow compulsory. So these are the rules for communicating information. So this includes syntax, semantics, and timings. This includes we will have the protocol will have some syntax and semantics will be there, and then timing is also provided in the protocol. So how this the development of the OSI is developed by International Organization for Standardization, which year in 1984. So this is the primary architectural model for computer communications. It is an architecture prepared model prepared for computer computer how the communication takes place. This gives the primary architecture model. A conceptual model, a conceptual model composed of 7 layers, each specified particular network functions. So we have seen that the this is a conceptual model, which will give this is a 5-layer network. This is a 7-layer OSI model, and which each specifies particular. So whatever the layers we have seen, 7 layers, each layer will have its own functions. So what all these will describe is, it will describe the information from a software application in one computer moves through a network medium to a software application in another computer. So here, what is the purpose of this OSI model is, it will describe, it will specify the information from a software application. So whatever the software application is there, for suppose the sender is having some application program that has to be communicated to the remote computer, remote computer. So that computer moves its application program through a network medium. So medium will be there. Through that medium, in the forthcoming classes, what is a network medium we will discuss. So in that through the network medium, it is communicated through the software application which is present in the another computer. That's why we require the OSI model. So what is the purpose of studying OSI? So this is an excellent model prepared for for the concepts and then understanding the protocol architectures. What are all the key point is, it is a modular, and it is modular. So module by module it is defined, and then hierarchical. So one after the other the process is performed. Boundaries between layers, there will be a boundary between layers, so that you call it as the interfaces. So there will be an interface for every layer. So this is the OSI reference model stack. It is explained with the here. It is at the one end of the computer. This is the OSI stack, and then at the other end of the this one, this is the protocol stack. So what is this one OSI stack? you will have the, if you go for the top to down approach, application layer, presentation layer, session layer, transport network, data link layer, and physical layer. So all these, whatever the in between, if we have any intermediate nodes or any node present or any devices present in between the sender and the receiver, we call it as the intermediate nodes in a network. So this will also have, so it is communicated with the network layer of the another network layer, data link layer to the data link, physical to the physical, like that. The whatever the network data physical layers are shown here, we call it as intermediate nodes. One node, second two nodes, three intermediate nodes in a network service. So OSI model headers and data. Here, as you see here, system A, let us say system A will have, this is a 764, all these are layers of the OSI reference model. The OSI reference model, we have the application layer, then seventh one is the application layer, then we have the presentation layer, session layer, transport, fourth one is this one is the, so here, as you see, application layer, presentation layer. Seventh one is application layer. Presentation layer is the sixth one, and then fifth one is the session layer, and fourth one is a transport layer. Third one is a network layer. Second one is a data link layer, and the first one is a physical. So all these are, and this one numbered as how the headers are formed, and then how the data is sent. So here the system A consists of all these layers. So this is a process performed here, and then they are linked with the network. So with the transmission medium, they are connected. So the physical layer is connected to the another physical layer at the remote end of the system B. So system B will also have the several layers of the OSI transport. That is, the different layers are 1 to 7 layers will be there. So here the data in the physical layer, data is sent, and then when it is communicated, whenever the data is whenever the system A want to communicate with system B, so what happens is the data is sent. Data is sent from the physical layer to the data link layer. In the data link layer, the data is added with the header. Header means some extra information is added, not to miss the data. Whatever the original data is there, that is added with the header details. So in the forthcoming classes, what are all the headers are added, that we will learn in the module 2. So here, as you see here in the another for the header 2, here with the data header 3 is added in the first one is the physical layer, this one is the data link layer, this one is the network layer. So in the network layer, another header is added, and in the another one, the header 4 is added, like that. So different for the information units, the headers are added, and then the information is sent. At the receiving end, all these headers are removed, and the original data is brought into the picture. So we'll get back the original signal when we send the information. So the lower layers, we call it as OSI lower layers are physical layer, layer 1, data link layer, layer 2, network layer, layer 3. OSI physical layer, so let us see elaborately the OSI physical layer. So it is responsible for transmission of bits. Physical layer, so whenever the information is sent, so machine understands in the form of bits. So this is responsible for whatever the information we are sending it is in the form of bits in the physical layer. So these physical layer always they are implemented through hardware. So all how the bits are by using the analog to digital converters, like that several equipments are there in the physical layer. Due to that one, whatever through the hardware, whatever the information is sent, it is converted into bits in the physical layer. So it encompasses, you have the electrical, it has the mechanical, electrical, and functional interfaces will be there. For example, RS-232 is a is an example for the OSI physical layer. So physical layer implementation, how the physical layer is implemented. This is the physical layer and second one data link layer. So in the physical layer, through the LAN, the Ethernet is connected and it is governed with the protocol IEEE 802.8, and then another one, the token ring IEEE 802.5, FDDI protocols are involved in the physical layer implementation, and then it is connected to different bands with different several protocols. OSI data link layer. So this is a data link layer. It is responsible for what is the next one is the second one. Second layer is the data link layer. The data link layer is responsible for the error free. So without errors, how to transmit the data. So whatever the data is there, it should not contain the errors. So hence so this data link layer will provide. It is responsible for giving the error free transmission. So it has to transmit the data reliably. So reliable transmission must take place. This is done in the data link layer by using the flow control and then error correction. Example HDLC. So OSI data link layer. So the data link layer, we have the different sublayers are there. One is the MAC sublayer, medium access control sublayer. Another layer is LLC link layer control sublayer. So by using this data link layer, we'll have these sublayers. So by using these sublayers, the OSI data link layer is going to communicate or to provide the error-free transmission. So how it is done, the process, everything we will discuss. This is the introduction of OSI. So let us discuss what are all the protocols or what are all the sub layers involved. Then elaborately we'll discuss all these things in the module 2. For error-free transmission of the data, error-free transmission, data link layer is provides that services. Next one is a OSI network layer. So this network layer, what is the responsibility of the network layer is, it is responsible for routing of messages through network. So whatever the messages are there, this will route the messages through the network. So through the network, when you want to route the messages, this network layer is responsible. So these are all. There are two types of switching used here: circuit switching and packet switching. This also in detail we'll discuss in the forthcoming classes as a part of the end of this module. So type of switching here, different types of switchings are used. One is the circuit switching, another one is the packet switching. So all these handles are routing between networks as well as through packet switching networks. So all these these packet switching networks are used to, packets means data. Data is sent to several networks by so that will be handled and routed. Routing means sending of information. So this is routed between networks. So this network layer is responsible for routing of messages. Next one is the network access layer. So this one is the network access layer. This comes under the network layer only. What this network access layer does is, it is concerned with exchange of data between computer and network. So this is used for exchanging of data, and it includes addressing. So what the network access layer does, it provides addressing. So it gives the address to that one. That is, we have physical addressing, we have the internet protocol addressing. All this is done in the network access layer, and the routing of the packets will take place, and prioritizing. That means in sequence, which packet has to be given priority, important, which is important to send, which has to be sent in sequence. All these things will be done by using the network access layer. So all these different networks, they require different software. So if you want to perform this networking, addressing, routing, prioritizing, all this, they are all concerned with the different softwares. So I add this layer. So they are concerned with different softwares. So here the example is X.25 standard for network access procedures on packet switching networks. The X.25 standard protocol is used for network access procedures on packet switching networks. OSI upper layers. So the upper layers, let us discuss the OSI upper layers. What are all the upper layers? They are nothing but the transport layer, session layer, presentation layer, the application layer. OSI transport layer. So this one, what is the purpose of this transport layer? So it isolates the messages from the lower and upper layers. So whatever the messages are there, this one will the transport layer will isolate these lower layer means data link layer, network layer, and the physical layer. This one isolates the lower layer to the upper layers. So also this in the transport layer, the packets are breakdown into message size. They are breakdown into message. That is, they are all segmented. That means they are all moduled into segments. So they are divided into segments in the transport layer. Monitors quality of communication channel. So it also monitors the quality of communication channel. What is the quality of services is provided in this particular layer. Selects most efficient communication service necessary for a given transmission. So what is the efficient communication way? How efficiently we can transmit the data like that? All these will be done in the by using the transport layer protocols. Why is a transport layer? And also the transport layer, it also delivers the reliable transfer of data information. So it is independent of nature of the application. So whatever may be the application, its service is transport layer is responsible for transferring of data, independent of the nature of the application. So whatever may be the application, it won't depend on the nature of the application, and includes like flow control and error checking. So there's here in the transport layer, flow controlling can be done. Error if error has occurred or not, that checking will be done. So flow control and error checking is done in the transport layer. Session layer, the next layer OSI layer is the session layer. So this session layer, what is the purpose of this session layer is it provides a logical connection between systems. So what it does logons, manages logons, whatever. When it has logon, it gives the timings for every session. That is when the system has logged on, when the system has logged off, and then when how which password, how to exchange a password, all these things, and password exchanging, and then log offs, all these things are done in the session layer. So it gives the timings for every session, terminates connection at the end of the session, as this gives the timing. So when to disconnect, when to connect, all these things is done by the OSI session layer. OSI presentation layer, it provides a format and code conversion services. So OSI presentation layer is used, it provides format. And so presentation layer provides the format, and code conversion also is done in the presentation layer. So how it is presented? Suppose if the file is in ASCII, so that has to be converted into the EBDIC. So this is a code, ASCII code. It is a code, and that has to be converted into extended binary decimal and decimal interchange. So this one is a binary decimal. So this one, it has to be converted ASCII code to the EBDIC code. So that conversion is done by using the OSI presentation layer. So this invokes character sequences to generate bold, italics, etc. on a printer. So what is a presentation layer is, as it name implies, that it will present the data. So how in what form it has to be delivered or presented. So how the characters has to be sequenced, and then how to generate bold, if you want to generate italics, etc. on a printer means this presentation layer is responsible for that. The last one of the OSI reference model is the OSI application layer. So this provides access to network for end user. So end user will access with the help of the application layer. The user capabilities are determined by what items are available on this layer. So logic needed to support various applications. So we require logic to support this application layers. Each type of application, that is what are all the different applications here, file transfer, remote access, all these different software on this layer is performed. So this provides the access to the network for end user. So what are all the applications of a network is distributed data communication involves three primary components. So all for the data communication, distributed data communications, it involves three primary. What are all the different components, primary components, networks, computers, and applications. And for this networking, computers, and application, three corresponding layers are, for example, so how to apply this one, the OSI layers is here. We want to perform the network, use the different components, networks, computers, and applications. The corresponding layers are network access layer for the networking. And then computers, so one computer to another computer, transport layer is involved. And applications, if you want to communicate, or if you applications, so with this we complete the OSI reference model, a brief discussion on the OSI reference model. 7 layers of OSI reference model we have discussed. So next class we will discuss about in the next lecture we are going to discuss about the difference between the OSI reference model and the TCP/IP protocols. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.